First chapter is physical quantities, and we'll start with units. Okay, 1.1 is the SI units. We'll start off with physical quantity first. Okay, what is the basic description of physical quantity? Then we have estimates. We need to know few estimates of some basic physical quantities because your first MCQ is usually they'll ask you to estimate a value. For example, they may ask, not in every paper, but sometimes they may ask maybe what is the kinetic energy of an Olympic runner. So there is some general information you need to have. I've shortlisted few common ones, and we'll look into it in detail in a while. Okay? Anyway, starting off with the first term of the syllabus, which is physical quantity. Now, when we talk about physical quantity, usually students visualize as something that is physical. That is not true. Physical quantity does not need to have a physical shape. Like time is not something physical, right? But it is a physical quantity, which brings us to a fact that there has to be a proper definition of physical quantity. Okay? So in physics, when we say a physical quantity, it means a quantity that can be measured by an instrument or can be calculated, and it needs to have a unit that is important. If there is a quantity which you can't measure, then definitely it's not a physical quantity. For example, mood, etc. Those are not physical quantities because you can't measure happiness and creativity, etc. Those are quantities. I mean, someday you might have a higher level of creativity, and sometime you might be a bit low or whatever, but you can't measure those. So physical quantity needs to be measured by an instrument, calculated, or it should have a unit. There was an MCQ in which they asked about refractive index. If you remember from your IGCSE, sine I over sine. Now, although we do calculate it, but refractive index is not a physical quantity because it doesn't have a unit. We just used to write 1.5, etc. So physical quantity has an important aspect, which is a quantity which has a unit. Fine. Anyway, time is an example. So the physical quantity is time. T is the symbol, magnitude, and unit. If this part is missing, we'll not call it a physical quantity. Okay? So just a brief introduction to what is a physical quantity. ठीक है. अच्छा, before we dive into detail calculations and so on, there are few estimates you have to kind of memorize or at least know the range of values. ठीक है कि इसके around ये होगा. For example, starting off with few masses, as a general knowledge you should know this. ठीक है कि atoms are in terms of 10 power minus 27, raindrop 0.03 grams. I won't ask you to memorize to the exact detail, but at least range पता होना चाहिए. Like coin is 2 grams, raindrop is way less than 1 gram. Meter rule, to multiple times they have asked 150 grams, 200 grams. ठीक है? These are not precise values, by the way, but range of values यही होने चाहिए. Adult person, multiple times they have asked. Normal car, 1500 kilograms. Some of the radius you should know. Atom is usually 10 power minus 10. Golf ball, tennis ball. We will be using these quantities. Earth का radius भी पता होना चाहिए 6400 kilometers. These values will not be given to you. Fine. Density. This is marked and important. ये तो आप बिल्कुल memorize कर ले. So many times they have asked about density of water, or maybe they ask about another quantity and you have to use density of water. So in gram per cm cube, it is 1. Kilogram per meter cube, this is 1000. ठीक है. This quantity is important. ये तो आप memorize कर लें. Steel या generally metals जो हैं transition metals, they are 7-8 times heavier. Speed जो है speed of sound in air, light in vacuum. Olympic runner, so many times they have asked about an Olympic runner, and it's usually the first MCQ. ठीक है. इसके अलावा नहीं, theory में नहीं होता. They won't ask for estimates. These are some of the common ones in terms of mass, radius, density, speed. ये तो आप याद कर लें इसको. Time taken, just I'll have a quick different average lifespan of a person, light to reach sun to earth, wavelengths ignore कर लें इस वक्त. We'll talk about this in the waves chapter. You can ignore the wavelengths. Resistivity, more about this in electricity. Number density, again electricity, ये आप ignore कर दें. ठीक है, Young's modulus डिफॉर्मेशन में आ जाएगा. एटमॉस्फेरिक प्रेशर, प्रेशर के चैप्टर में. अच्छा, so some MCQs I wanted to highlight जो estimates के आते हैं. This is how they are going to structure a question. What is a reasonable estimate? ठीक है, of density of sand. तो and it's a question from March 21 and most probably the first MCQ. D आंसर करेक्ट है क्योंकि डी ऑप्शन में जो डेंसिटी है वो ज्यादा है. ठीक है, ए हम इसलिए वैसे मैं बता देता हूँ, बाकी ऑप्शंस पे भी वी हैव टू बी क्लियर विथ. एमसीक्यूज में we need to know why are we rejecting rest of the options as well. देखिए, अगर ग्राम पर सीएम क्यूब में मैं कंपेयर करूंगा, वाटर की डेंसिटी 1 ग्राम पर सीएम क्यूब है. ऑप्शन ए बता रहा है कि सैंड इज 200 ग्राम्स पर सीएम क्यूब. ठीक है, अब देखें, सैंड इज डेंसर बट 200 टाइम्स डेंसर तो नहीं होगा ना. आप सोचें कि एक बीकर है, उसमें 50 ग्राम्स वाटर है और दूसरा बीकर है सेम वॉल्यूम, उसमें सैंड है, तो वो मोस्ट प्रोबेबली डबल होगा लेकिन 200 टाइम्स ज्यादा तो नहीं होगा ना, हैवी नहीं होगा. राइट, दैट इज व्हाई वी रिजेक्ट ए, not because of its unit. We reject A because it's 200 times denser. This is not possible. ठीक है, B में देखें, it's 2000 ग्राम पर सीएम क्यूब. अगेन B is also not possible. ये तो हो नहीं सकता कि आपके पास इक्वल वॉल्यूम हो दो कंटेनर्स में, एक में वाटर एक में सैंड है, एंड द सैंड इज 2000 टाइम्स हैवियर. ये तो हो नहीं सकता. सी में तो प्रॉब्लम ये है कि इट इज 50 टाइम्स लेस. किलोग्राम पर मीटर क्यूब में तो 20 आ रहा है. दिस इज नॉट पॉसिबल. डी इज करेक्ट. 2 टाइम्स हैवियर इज फाइन. ठीक है, जून 21 का एमसीक्यू है, व्हाट इज अ रीजनेबल एस्टिमेट ऑफ वॉल्यूम ऑफ एन एडल्ट पर्सन. नो फर्दर डाटा गिवन, कुछ भी नहीं दिया हुआ, और आपसे कह रहे हैं कि क्या एस्टिमेट. आप जो है देखें, rather than actually measuring volume, ये बड़ा complicated हो जाएगा अगर आप इसको सिलेंडर कंसिडर करें या whatever. If we compare it with density of water, देखें, our body has 70-80, आप जो बायो के स्टूडेंट्स उनको ज़्यादा आइडिया होगा, मोस्टली वाटर. एंड when we swim, हमें पता है कि we can control our density by breathing air in or out. We are around water, मतलब we can easily float on water or dive in water. मतलब बहुत ज्यादा डिफरेंट नहीं होगा. अगर एवरेज ह्यूमन आप 80 लेते हैं, 70 लेते हैं, कोई स्ट्रेट फॉरवर्ड रूल नहीं है, आप इसके अराउंड ले लें. फाइंड डेंसिटी इन ईच केस. आप ऑप्शन ए के लिए डेंसिटी फाइंड, 80 डिवाइड बाय 0.1 तो 800 आता है, विच इज क्वाइट क्लोज टू 1000. Okay, we'll keep this option open for a while. ऑप्शन बी जब आप देखते हैं, 80 डिवाइड बाय 0.5, 160 is just way too light. मतलब
Yes,
ये
sir.
तो बहुत ही लाइट हो गया वाटर के मुकाबले में. इतना भी नहीं है, मतलब हम थोड़ा सा अगर इफ वी ब्रीथ आउट तो वी कैन इजीली डाइव इन, वी कैन गो बिलो द सरफेस ऑफ वाटर वेरी इजीली. सो 160 इज वे टू लाइट. और सी तो फिर उससे भी लाइटर हो गया. ठीक है, 80 डिवाइड बाय 1 इज 80 किलोग्राम पर मीटर क्यूब. और डी तो इट कीप्स ऑन डिक्रीजिंग एक्चुअली, अराउंड वाटर ए ही आता है. दिस एमसीक्यू इज फ्रॉम एस समर्स 20 मई जून 20 का एमसीक्यू है. अगेन रीजनेबल एस्टिमेट.
सर एवरेज कार का मार्क्स कितना हो सकता है सर?
अच्छा, ये मैंने उस लिस्ट में भी प्रोवाइड किया है. रिमेंबर इट्स अराउंड 1500. आप 1200 1600 इस तरह ले सकते हैं. जस्ट कीप इट 1500 kilograms.
सर सी
विल फाइंड आउट. ठीक है, और इन टर्म्स ऑफ 10 अगर हम देखें, राउंड ऑफ कर दें. या इज दिस क्लियर? ठीक है जी. एनी आइडिया और शुड वी डिस्कस?
I think this one is kind of like way too complicated.
या अच्छा, इसमें सिंपल ये है, स्टैंडर्ड फुटबॉल दे आर रेफरिंग टू अ स्फीयर. फर्स्ट वी नीड टू नो द फॉर्मूला फॉर स्फीयर. ठीक है, दैट इज 4/3 pi r cube. ठीक है, radius of football, this you have to keep in mind. I mean, during your exam you might have the geometry box on you, so you might be needing to visualize a football and see how much of radius it's going to have approximately. But they have asked this multiple times, so just keep in mind radius of football is going to be around 11, 10.5, 11, 10 centimeter, etc. So all you have to do is just put in this formula and you get about 5580, and we can round it off to 6000 cm3. Okay? So do note down any additional formula or any piece of information that you might find important. So B should be the correct answer. It is something that separates math from physics. Like in math, you have, if you want to find the value of x, if it's 54.6, fine. Like it doesn't matter. But physics, if you find density as 54.6 or whatever gram per centimeter cube, then it should be, the answers should be reasonable. Like you should know, does it make sense or not? So if you are finding density of sand and it turns out to be 54.6, well, you should reject your answer. Okay? Whatever in the presence of air resistance. And in presence of air resistance, if your answer is 12.5 meter per second square, well, that's not a reasonable answer, because in the absence, if it's 9.81, then in the presence of air, it should be obviously less than 9.81. Your answer should be reasonably less than 9, like 7, 6, etc. Fine.
Yep.
So that's the whole point of this topic. You should know the reasonable values. Read this MCQ June 18. They have given us thickness of a gold leaf, a sheet of gold actually, and they've given us radius of each atom. I'll give you a hint. If you want to remove micro, you multiply by -6. If you want to remove pico, picometers is one of the prefix, so you multiply by 10 raised to power -12. They have given us the total thickness, which is 0.125 in 10 power -6. And for individual atom, how much length does it occupy in the total? They've given us the radius, right? But I have to multiply by 2, because each layer of atom will occupy the length equal to the diameter. इतनी जगह cover करेगा ना, diameter के equivalent. So now it comes down to simple ratio. Total length ये है, every layer is this much, then how many layers can we have? Either you can use simple ratio or just divide के one layer of atom. This is one layer. Total length में कितने layers आएंगे? Simple cross multiply करें. X times this times this. तो ये 359 या 400 आता है. Start में there is a steep learning curve, क्योंकि MCQs की difficulty level है ज़्यादा, but eventually you will get a hang of it. मतलब clear होता जाएगा कि what is their expectation. So it's not as straightforward as IGCSE. That is what makes it difficult to score. Give this MCQ a try. So A is incorrect. Grain of sand मैंने start में बताया था, it's in milligrams. 1 gram जो है 110 power minus 3 kilogram is 1 gram. जब 0.2 grams होता है, so how can a tiny piece be 1 gram? ठीक है, coin के साथ अब compare. So 1 gram is too heavy for a grain of sand. Tennis ball, we just found out 6,000 उसका आंसर था. And this in cm cube is 10,000. So tennis ball should have value less than 6,000. So ये MCQs जितने हम डिस्कस कर रहे हैं, these are important ones. इससे आपके काफी MCQs जो है interlink होके you can have a better idea of related MCQs. So if football had a volume of 6,000, then tennis ball should be less than 6,000. तो ये तो 10,000 आ रहा है, which is a lot for a tennis ball. ठीक है, C ठीक है. बस में वैल्यूज भी पुट करें ना, एप्पल इज अबाउट 0.1 किलोग्राम और हाइट अबाउट 1 मीटर यूज करें, दिस इज 1 जूल, तो सी इज करेक्ट. डी जो है 10,000 वॉट फॉर पावर ऑफ लाइट, दैट इज टू मच. जो इलेक्ट्रिक गीजर्स या इलेक्ट्रिक हीटर्स होते हैं, दैट इज बेयरली 1.2 और 1 किलोवाट. ये 10 किलोवाट की बात कर रहे हैं कि दैट इज लाइट बल्ब. ये अबाउट 200 वॉट्स मैक्सिमम हो सकता है. ठीक है, लाइट बल्ब जब आप देखते हैं, अभी तो एनर्जी सेवर्स हैं, दे आर लाइक 10-20 वॉट्स एटसेट्रा. लेकिन जब ये लाइट बल्ब कहते हैं, इट मींस दे आर रेफरिंग टू द फिलामेंट लैंप वंस, एंड दे विल बी एट मैक्स 150-200 वॉट्स. ठीक है, तो 10,000 तो बहुत ही ज्यादा है, सो डी विल बी रिजेक्टेड. व्हाट वी आर गोइंग टू डिस्कस इज base quantities and derived quantities. That is where your actual course content start from. Reasonable estimates, where as such you don't have syllabus content, but first MCQ is from reasonable estimates. अच्छा, classification of physical quantities पे जब हम बात करते हैं, they are broadly of two types. There are 7 base quantities. They have been categorized by a group of scientists. They are fundamental quantities and they cannot be further simplified. Okay? Other quantities are called derived quantities, and we have a whole list of derived. Base quantities, you need to note it down because they're fixed and we'll be using them again and again in the coming slides. Okay? So base quantities are fundamental quantities and they are the simplest quantities. You can't further simplify it. Derive, however, can be expressed in terms of base. Okay? So we'll look into more detail in a while, but I want you to note down the base quantities because you have to memorize these. So length, time, mass, along with its unit, you have to write. Temperature with capital K. Current, these are the 5 important ones. We do have amount of substance and light intensity, but we are not going to use much in the first year of physics. Amount of substance is used a lot in second year of physics, in thermal physics, but not over here. But do note down the 5 important base quantities. Okay? If you talk about derived quantities, then we don't have a complete list because it keeps on going. You name any quantity which is not base is going to be derived. These are all derived quantities and many other, but these are some of the common ones.
Sir, the K in kgs is small, and for temperature Kelvin it is capitalized, right?
Yeah. So the first task that we have to do in these base quantities and derived quantities is in their units. That is the first thing we have to do. We should be able to convert derived units in terms of base units. And why do we have to do it, practically speaking? I'll discuss in the end. But that is the first thing that you have to do. So if we come up with any derived unit like Newton, maybe, and you want to convert into base unit, because Newton is not a base unit, it is unit of force which is derived. Now Newton or any other derived unit can be converted into base unit by following these steps. So the first step is you select a formula and then you simply put all the units till you end up with the base units. Okay? For example, we'll start with Newton. So which formula should I consider for Newton? Yes, mass times acceleration. And all you have to do is put the units. So mass is kilogram and acceleration is meters per second square. And avoid using slash over here because we'll be mixing more and more units in a while. So it's always suggested to avoid slash and rather write it ms minus 2. So now if you look at the units, are they all base units? Kilogram, meters, and second? Yeah. Yes, so, right. So which means that if someone writes 3.0 Newton or some other student writes 3.0 ms minus 2, they both convey the same information. So that is how you convert base units, derived units in terms of base units. Similarly, we can go for other important examples. These are the examples, they're so common. I would suggest you should, this answer should be on your fingertips because there are many other which we are going to solve in a while. But these are the basic ones. We'll go for the basic formula, force into distance. And we'll just keep on putting the units. Newton and distance is meter. Newton we have just derived. So if I put this instead of Newton in the next step and combine the powers, m and m will make m square. So you're right. Kg m square s minus 2. Okay? And this is such a common one. इस पे in your MCQs, if you get joules etc., straight away आप लिख लें kg m square s minus 2. ठीक है? अच्छा, यहाँ पे एक पॉइंट आ जाता है कि व्हाट इफ समवन यूजेस अनदर फार्मूला, क्योंकि जूल्स come from different formulas. What if someone use half mv square? Whichever formula you use, as long as it gives the answer in joules, you should get the same answer. In this case, however, half is not a physical quantity, does not have any unit, so we'll ignore half. We can't put any unit for half. We are only interested in the physical quantities. So instead of m, which is mass, I'll put kilograms. Instead of V, I'll put meters per second and whole square. If I open the bracket, square will go with both of them. So this is what it becomes, kg m square s minus 2. Okay, so if you look at the answer, it is same. This brings us to a fact that what if somewhere in future we find another formula if we are able to derive for energy, because there's still a lot to be discovered if you talk about space physics, how black matter and dark energy and all of that, how they interact, how intergalactic space is filled, is a lot to be discovered in terms of energy. And if we come up with some new formula, they're not going to straight away apply it. They'll first check the base unit. If it turns out to be whatever the formula is, if the final answer is kg m square s minus 2, it means the formula is good to go. Okay? So that is one of the use of this whole process. It helps us verify new formulas. Watts का आप try कर लें. Think of what was like the physical quantity for which the answer was in watts, and what is going to be the final answer. Can you give it a try? Power, watts is a unit of power, and work done over time, joules per second. Joule we already know from the previous part, kg m square s minus 2 whole divided by second s minus 3. Here that is correct. It's a unit of pressure, force over area, Newton over meter square, and Newton we already know from this. So we'll put kg ms minus 2 and whole divided by m square. And when we simplify, we get kg m minus 1 s minus 2. Coulomb का आपके ख्याल में क्या आंसर होगा? If I want you to express Coulomb in terms of base units, would be current into time, so ampere into second. ठीक है? A common mistake would be using V is equal to IR. उसमें R आ जाता है, and R is again going to be a challenge. There are different ways to go about. You can use a simple definition of voltage, which is work done per unit charge. So from the previous slide, we know work done is kgm square s minus 2, and we know charge is AS. If we simplify, the s goes up, becomes minus 3, a goes to the numerator and becomes minus 1. Can you try for ohms? Yeah, we can use V over I. We just calculated V. This is already voltage, right? So we just have to divide by 1 more ampere, and that will make it minus 2. You're right. That's a small variation. They can give you some formula, and they'll specify one of the physical quantity, find its base units. F is the force, M and M are the masses, R is the distance. So what do you think we should do in this case? इसका try कर लें, आपके पास क्या answer आएगा? Then we'll find out. The first step that we have to do is we need to make G the subject. ठीक है, तो ये cross multiply करेंगे. And the next step is to put the units. F is Newton, R square is meter square, and then M and M are the 2 kilograms. So kilogram square, okay? Because the two masses are being multiplied. Isme meter square is fine, kilogram square is fine, but the Newton is derived unit. So we have to replace that. This is the Newton part. And if we further simplify, this is what we get. Per kilogram, m cube s minus 2. Yes, you're right. So we have this MCQ from March 22. The question is, what could not be a measurement of physical quantity? Capital T refers to terameters. So tera is 12. So it has a unit, so it's a physical quantity. They're asking which one is not. I think because A is true, 10 Kelvin can be a physical quantity. B, if you simplify, instead of joule, if you write Newton meter, then it cancels out. It has no units. If you look at C, if you simplify, you do end up with meters in the end. That is a physical quantity. And this is also a physical quantity. The only physical quantity, the option which is not a physical quantity, is B, because it has no units. So homogeneity, homogeneous equation is when base unit of each term is same. Now what we mean by this is look into an example ताकि idea clear हो जाए कि what we are discussing over here. आपके पास अगर एक formula है s is equal to ut plus half at square, this formula is from kinematics and it gives us the value for displacement. ठीक है? If you are given initial velocity u and after a certain time it can give you how much of the displacement has been covered by an object in motion. Now the idea is every equation in physics is homogeneous. ठीक है? Homogeneous का मतलब ये होता है कि the terms should have the same base unit. इसमें इस वक्त 3 terms आ रहे हैं. ठीक है? This is the first term. This as a whole is the second term. ये ना हो कि आप कहें कि u and t are 2 different terms. This is one term. ठीक है? This is the third term. Remember, term is separated from one another by equal sign or plus or minus. ठीक है? जिनका मैथ है, you might be knowing this in binomial theorem. इसमें भी term जो होता है, it is separated by plus or minus. ठीक है? Now the idea is, I have 3 terms right now. Every term, when I simplify, should have the same base unit. So I'll start with the s first. S is displacement and U is the initial velocity, A is acceleration, T is time. I'll start with S first. The unit of S is meters, right? If I look at the second term, UT, so if I put the units meters per second into second, I get the same unit, meters. Okay? And if I look at the third term, which is half at square, and if I put the units, if I get the same meters as the final answer, it means this equation is verified on the basis of base units and it's a correct equation. If I don't get meters, it means this is not homogeneous, which means practically you can't use it. ठीक है? देख लेते हैं half at square. Half has to be ignored. Acceleration is meters per second square. Time square is s square. If I simplify, what do I get? -2 and s2 cancel out, and I get meters. So if each term has the same base unit, we can say an equation is homogeneous. ठीक है? Simple term है जो कि बताता है कि if every term has the same base unit or not. Whichever formula you pick in physics, it is going to be homogeneous no matter what. ठीक है? इसका left right equal होगा. अगर कोई third term है वो भी equal होगा. I'll go for another example, then I'll take questions if you have. For example, मैं आपसे कहता हूँ ये formula verify करें कि if it's homogeneous or not. What you are going to do is you'll pick this term and simplify, and then you'll pick this term. There's no third term over here. So we have 2 terms and we have to look into the base units if they are same or not. So P is pressure, rho is density, G is acceleration of free fall, H is height or depth. So I'll go for P first. P is force over area, Newton per meter square. I get kgms minus 2 divided by m square, kg m minus 1 s minus 2. This is the final base unit on the left side. Okay? Now I'll verify the right side. If right side has the same base unit, it means the formula is homogeneous. So I'll put the units. Density is mass over volume, kg m minus 3. G is ms minus 2. And then we have m square. If I simplify, I get kg s minus 2. Let me do this part again. So left side we get this, rho g square ka kar dete hain. Density is kg m minus 3. Gravitational field strength, the acceleration of free fall is ms minus 2 and height is m square. ठीक है? इसको अगर हम सिंप्लीफाई करेंगे, what do we get? kg तो एक ही है, m minus 3 and then m3. What do I get? Don't they cancel out? देख लें अगर कहीं पे कोई error है तो मुझे बता दें. So they cancel out, so m is no longer there, and then you have s minus 2 left. This is your final answer, which means if we check left and right, they're not equal. So according to the law of homogeneity, this is not homogeneous. So homogeneous is when each term has the same base unit. Whether there are 3 terms, 4 terms, whatever, they should have the same base unit. यहाँ पे base unit same नहीं आ रहे, so not homogeneous. This is homogeneous. Is this clear?
Sir, how can we access notes and worksheets?
Notes आप simply ये कर सकते हैं कि you can go to this website आप साइन अप कर लें तो नोट्स भी अवेलेबल हैं, और अगर आप टॉपिकल पेपर्स हैं जस्ट सेलेक्ट कैम्ब्रिज ए लेवल्स फिजिक्स। अब जिस तरह
Okay.
आज हमने 1.1 किया है, आप इसको क्रिएट कर लें एंड यू कैन कीप ऑन प्रैक्टिसिंग दीज MCQs, कैन स्टार्ट एग्जाम। इस तरह आप ये क्वेश्चन है तो असिस्टेंस ऑन ऑफ आप चेक कर सकते हैं विच वन इज करेक्ट विच वन इज नॉट करेक्ट। ठीक है, तो आप ये ट्राई कर लें, इसमें कोई क्वेश्चन हो तो वी कैन डिस्कस।
Thank you, sir.
ठीक है, वेलकम। They're asking for the base units of mu. Some formula, not in syllabus, but they can include. All we have to do is put the units. E is charge, so that will be AS per kilogram. M is mass, and this letter is known as tau, by the way. ठीक है, जैसे lambda होता है, ये AS में नहीं है लेकिन टाओ इसे कहते हैं। ठीक है, इट्स काइंड ऑफ अ टी, पाई की तरह होता है लेकिन दिस पार्ट इज मिसिंग। एनीवे, दैट इज टाइम टेकन, सो इट हैज टू बी सेकंड्स। So instead of coulomb, I can put AS and then it becomes square. So yeah, AS square per kilogram. You're right. जो B बता रहे हैं that is correct. Which physical quantity could have unit of n s square m minus 1? देखिए, what we can do is can express this in terms of base unit. तो न्यूटन को अगर मैं एक्सप्रेस करूं in terms of base unit, do you recall न्यूटन किसकी इक्वल आ रहा था? Yeah, kgms minus 2, right? So न्यूटन की जगह मैंने ये लिख लिया. If I simplify, it seems that m and m will cancel, so I'm left with kilograms. S square and s minus 2. So it seems to be, yes, Kisa, you're right. C answer सही आ रहा है. Which combination of units could be used for expressing the power dissipated? Dissipated in resistor is just for confusion. Power तो कहीं पे भी power हो सकता है. By definition, power is energy by time. तो एनर्जी का यूनिट जूल है और टाइम इज पर सेकेंड, राइट? मतलब डिवाइड बाय सेकेंड। एनर्जी जो है वो बेसिकली फोर्स इनटू डिस्टेंस होता है, न्यूटन मीटर्स, तो न्यूटन मीटर पर सेकेंड, तो यही आता है। नवंबर 20, ये MCQ, सो इट टेक्स अ बिट ऑफ टाइम।
जी सर, बिकॉज स्पीड है ना।
यस, एंड टी की जगह बिकॉज इट्स न्यूटन, और न्यूटन की जगह डिड यू राइट kgms minus 2, लेकिन हमें
जी सर।
पावर नहीं पता। ठीक है, अब म्यू जो है इट्स सम न्यू क्वांटिटी, लेकिन इट्स वेरी ऑब्वियस, kg per unit length, so what do we write? kg per meter, right? और पावर q। अच्छा, अब दिस इज अ प्रॉब्लम, इससे आगे हम नहीं जा सकते। ठीक है, लेफ्ट साइड पर ms-1 है, राइट साइड पर some unknowns, या हम एक काम कर सकते हैं, if we expand by opening the brackets, बल्कि तीनों के साथ kg power p हो गया, m power p and s power minus 2p। इसी तरह if I open this bracket, what will I get? Will I get kg power q and m power minus 1 into q is minus q? देखिए, लेफ्ट और राइट, नाउ आई कैन नॉट गो फर्दर देन दिस, दिस टू मैनी अननोन्स एक्चुअली। एक बात हमें पता है कि फिजिक्स में सारे इक्वेशंस होमोजेनस है, व्हिच मींस द पावर ऑन लेफ्ट एंड राइट शुड बी इक्वल। तो बेस्ड ऑन दिस, इफ आई जस्ट पिक द मीटर्स, इफ आई जस्ट पिक द सेकेंड्स, देखिए सेकेंड का पावर -1 है, तो राइट पे भी तो पावर -1 ही होगा, फाइन, व्हिच मींस आई शुड make left and right side equal to find the unknown। देखिए, the powers should be equal, तो मैं इसको equate कर सकता हूँ। It comes down to a simple math problem कि जब मुझे पता है कि physics के सारे equations homogeneous हैं, which means the quantities on left and right, जो उसके units हैं, they should be same, which means I can make their power same। तो -1 will be equal to -2p। तो p की वैल्यू फिर अगर मैं सब्जेक्ट बनाऊं, इट विल बी 1/2। मेरे पास -1/2 इनकरेक्ट है, और मेरे पास सी डी में ऑप्शन आ जाता है। देयर इज नो अदर इजियर अप्रोच, दैट्स द सिंपलेस्ट वे टू लुक एट। क्यू के लिए यू कैन कंसिडर मीटर्स, आप कंसिडर कर लें लेफ्ट और राइट। तो लेफ्ट पे आपके पास आ रहा है जस्ट, और राइट साइड पर एक m पावर p है, m पावर -q, राइट। तो लेफ्ट पे इसका पावर 1 है, और राइट पे ये होगा p माइनस क्यू, क्योंकि मल्टीप्लिकेशन में पावर्स आर एडेड, m p m माइनस क्यू, बेसिक इंडिसेस ओ लेवल मैथ है, तो p माइनस क्यू आ जाता है। comparing the powers. Yeah, if you put the value of half over here, तो q की value फिर आपके पास c आनी चाहिए. Half minus 1 is minus half. अच्छा, अब this very MCQ, I've seen this like 4 times or 3 times in different papers. It's a June 19, but there's so many papers which has this very MCQ somehow. Pi को हम ignore करेंगे, ठीक है? Pi doesn't have a unit, 4 doesn't have a unit. R is radius, तो radius को हम ignore नहीं कर सकते, so we have to put meter power 2. This symbol is some constant which we don't know what is it, but they have given us the unit, so fine. And then temperature is Kelvin, तो फिर आप Kelvin power 4. लेकिन सिग्मा में आपने ये सिंबल वैसे सिग्मा शो करता है कि 4 and pi doesn't have, they don't have to be considered. Radius square है तो meter square हो गया. Instead of this symbol, I'll write this. And instead of temperature power 4, what do I write? Kelvin power 4, right? And watts we have derived multiple times. That is energy per unit time, joule per second. And joule is kg m square s minus 2 or minus 3. आंसर जो है सी आ रहा है, इस क्लास में डिस्कस कर लेंगे. इसमें देखिए द अननोन इज n, सो फर्स्ट स्टेप यही होता है ना, जो अननोन होता है दैट शुड बी मेड द सब्जेक्ट. So I'll make Vn the subject and these ms minus 1, right? But we don't know n, so I'll just ignore n. I'll just write it as it is. 2 has to be ignored. It's not a physical quantity. Newton की जगह we put kgms minus 2. Density is mass per unit volume and area is meter square. And CD, which is drag coefficient, doesn't have a unit. This is what they have specified over here. So if I simplify, I get kilogram cancels, m and m minus 2. One of the m cancels out. So yeah, m square s minus 2. Now I cannot move further than this, but what I know for sure that if you look at any equation in physics, left and right should be equal. The question is, what should be the value of n to make it equal to the right side? N has to be 2. Okay? The next topic is prefixes. Apparently seems to be a very easy topic because you're already familiar with these prefixes except for 1 or 2. But again, since we are talking about A levels, difficulty level is a little higher, especially in MCQs. So prefixes, I don't think any prefix, most of them you're already familiar with. Centi, milli, micro, nano, etc. Okay, pico, I think this might be new, which is 10 power minus 12. Tera is 10 power 12. So this is, these are the prefixes that you should be familiar with. Now, it's not just memorizing these values that you should memorize, obviously, but we need to know how to process them. So even the processing is same as of IGCSE, in which what we do is if we remove a prefix, we multiply by its value. If we add a prefix, we divide, and for area and volume, we take square and cube. Okay? So for example, if we look at this one, even the examples initially are same. Do you think if I want to convert gigameter into meter, what do I do? Because you're removing a prefix, so you just multiply by 10 power 9. Okay? And over here, again, you're removing micro, so you'll just multiply by 10 power minus 6. So you may note down any prefix that you find new. Tera की value अगर लिखते हैं या any prefix that you find difficult. Amperes into deciamperes, you're adding a prefix, so you divide by the value of deci. And similarly, grams to kilograms, very easy. Centimeter to millimeter. Now, it's into 10. It's a common conversion, but we can use the rules. We are removing centi, so we multiply by minus 2. And we are incorporating milli to it, so we divide by 10 power minus 3. So that makes it 120. Again, straightforward. Nanometers to micrometers, same idea. Multiply by 10 power minus 9 because this is the prefix that we are removing, and we are adding micro. So we'll divide by 10 power minus 6. Okay? In case of volume, the process is same. So if I'm removing deci, I'll multiply by 10 power minus 1. And if I'm adding centi, I'll divide by 10 power minus 2. One additional step is to take cube of it. So in case of volume, you have to take cube of the prefix. Remember not to take cube of the value, obviously. So 24 dm cube we know from chemistry as well. It's 24,000 cm cube based on this conversion. Similarly, for millimeter square into kilometer square, the method is no different. We'll multiply by the value of prefix milli and then add kilo. So we'll divide by 10 power 3. एक स्क्वायर बिकॉज इट्स एन एरिया मार्च 22 का ये एमसीक्यू है ए ठीक है एनीवन एल्स वी आर रिमूविंग अ प्रीफिक्स सो हम गीगा की वैल्यू मल्टीप्लाई करेंगे तो कैलकुलेटर में जब आप इसको पुट करते हैं तो ये आपको फाइनल आंसर ये दे ठीक है so removing a prefix is just multiply whatever the value is whether it's giga whether it's mega kilo deci micro जो भी prefix है as long as you're removing it you need to multiply by the value. अच्छा, November 20. इसका देख लें. What answer do you think we have? They're asking which time interval is the shortest. We have a mix of prefixes, so it's going to be tough if I just look at the values and I just keep on thinking किसका कौन सा आंसर होगा. We'll make it simple. Remove prefix in every case. मतलब हर केस में आप जो है इसको seconds में convert कर लें. रिमूविंग प्रीफिक्स का मतलब ये होता है कि यू हैव टू मल्टीप्लाई बाय द वैल्यू ऑफ प्रीफिक्स मतलब ऑप्शन ए में आई मल्टीप्लाई बाय -3 तो ये वैल्यू आती है ठीक है बी में ये नैनो शो कर रहा है नैनो की वैल्यू टेबल में जो 10 पावर -9 गिवन है एंड मल्टीप्लाई दिस इज व्हाट आई गेट 500,000 पीको सेकंड पीको टेबल के मुताबिक इट्स 10 पावर -12 तो फर्स्ट स्लाइड जो था जिसमें टेबल था So once they are all converted to seconds, isn't it easier to compare which one is the smallest value? C और D तो same ही है, वो तो बिल्कुल reject हो गए. -8 का there are too many zeros involved. 7 zeros, 0.000. 7 zeros and फिर 5 है. So this is much smaller. It has to be B. November 21, give this a try. I think that will be an easy way. आप इसको भी convert कर लें. और इन सब को भी कन्वर्ट कर लें देख लें कि इसका आंसर सेम आ अगर आप इसको कन्वर्ट करेंगे डेसी रिमूव करेंगे सो 10 पावर -1 इफ यू रिमूव प्रीफिक्स इन एवरी केस ओनली ऑप्शन ए इज टर्निंग आउट टू बी द सेम ठीक है आप इससे भी डेसी हटा दें जस्ट कन्वर्ट इनटू जूल्स और इस इन सब से 1 बाय 1 ये हटाते जाएं आपने इस पूरे वैल्यू को एज अ सिंगल वैल्यू कंसिडर करना है ये ना हो कि आप इसको मिक्स करें कि 10 पावर 3 इट्स नॉट अ प्रीफिक्स ये तो वैल्यू है ठीक है इसको आपको नहीं चेंज करना जस्ट मिली आपने मल्टीप्लाई करना है हमने प्रीफिक्सेस सबसे हटाए सिर्फ ये देखा है किसकी वैल्यू सेम आ रही है 43 डेसीजूल के साथ सो गिव दिस अ ट्राई माइट बी अ बिट चैलेंजिंग क्योंकि 2 प्रीफिक्सेस एट अ टाइम चेंज हो रहे हैं फिर डेंसिटी पूछ रहा है सो ये देख लें इसका आंसर आ रहा है कि विल फाइंड आउट व्हाट वी हैव टू डू इज they want kilogram and meter cube so we have to convert this into kilograms this into meter cube so we'll do it individually 4.8 micro into kilo so multiply by -6 divide by 10 power 3 this is in kilograms and in dm cube we're just removing deci but we have to take the cube. There's no division because we don't have any prefix. We are just removing a prefix. This is a volume, and when you divide mass over volume, you get 4.0 in 10 power -6. C is correct, you're right. So that was about prefixes, a relatively short topic. So we don't get too many questions in theory, but yeah, an MCQ or so. Next is errors and uncertainty. We'll start with understanding significant figures. And it's not just for this topic. These significant figures are going to play their role in rounding off values or recording data, even in paper 3, or even beyond that, like in A levels, paper 4, 5. We'll be using these rules that we understand over here. So it kind of forms a baseline for all the calculations and even in higher classes. So basic rules, I think you are already familiar with from IGCSE math. In significant figures, if you have non-zero numbers, then we say it's 4 significant figures. But if there is a zero in the middle, it is still significant. The zeros in the middle, they carry an important information. So they are going to be significant. Okay? Zeros to the left, however, are not significant. So if you have 0.006, these zeros, they don't carry much information. So we do not consider them as significant. 0.34, again, 2 significant figures and 1 significant figure. Zeros to the right are significant if decimal is involved. So for example, 39.0, then this zero does carry information. It tells us about the least count of instrument. So zeros to the right are considered significant. By significant, we mean it is important and it carries some information. We'll talk more about this later on. So in this case, 230.00 decimal is there. All these zeros are significant. So as a whole, we call it 5 significant figures. Okay? Now, fifth point we need to understand in a little more detail. If you do not have decimal 6,000, then this is a problem. Do we consider these zeros as significant or not? That is a question. So if they don't give you further information, then every number is fine. Like if you call it 1, 2, 3, 4, all are acceptable values. But if extra information is given, now hear me out on this one. If this is an electronic balance, for example, and this balance can measure the values throughout for all the zeros, they can change, which means the first value is 6,000, then we have 6,001, 6,002, and so on. It means this zero is important and it can change. So in this case, it will be 4 significant figures. But if extra information is not given, then all the values are acceptable. At the same time, if you have another electronic balance or whatever instrument it is, it can measure 6,000, but the next possible value is 6,000 and then 6,020 and so on, which means this zero doesn't change. So it doesn't carry much of information. In this case, I'll consider these as 3 significant figures. Does it make sense? If additional detail is given about instrument, I give you a value 6,000 and I ask how many significant figures are there. If you give this as 1, 2, 3, 4, all answers are acceptable. But if I give you additional information and I say, no, this is actually an ammeter which gives us value in milliamperes. One value is 6,000, the other possible is 6,100 and 6,200, which means this instrument is designed in such a way that it gives you value to the nearest 100, which means the first 2 zeros cannot change. How many significant figures are there in this number?
2.
2. Because 2 digits, the last 2 digits, they don't change. So if the values do not change for an instrument, then it is not significant. So in this case, this zero is significant, but these 2 zeros are not significant because they're not changing. And same goes for this one, 6,000, 7,000, 8,000. So which means all of these zeros are insignificant. The only significant figure is the first digit, so 1 significant, which helps us conclude that significant figure gives us an idea about instruments. So we are not blindly memorizing facts and figures. We are going to apply the significant figures on instruments. Especially paper 3, significant figures will play an important role in how you record data in your tables and graphs. Now, this is more important. The rules that are to be followed in significant figures while considering significant figures in decimal places. Now, the first rule is during addition and subtraction, primarily used in change in temperature, etc., because you subtract 2 values. Now, remember, rounding off should not be random. It follows a very specific rule. If you want to round off your answer, and you have to obviously in your especially practicals, but even in theory. If it is an outcome of addition and subtraction, your answer should have least number of decimal places, which means what? If I were to add these two values, the left side, this number has 4 decimal places. The right one has 1 decimal place, which means if I add these two from the calculator, I'll get this value. But I will round this off such that I should have least decimal place. So 4 decimal place and 1 decimal place. My answer should be 1 decimal place. So we have 2 decimal place. So you think this is the final answer?
Yeah, that's what I think.
Anyone else? Do you all?
306 only.
Yeah, 306 only, because you see no decimal place or 0 decimal place and 2 decimal place. So I have to go for the least. So my final answer should not have any decimal place. So this question, by the way, was asked in paper 4 physics, in thermal physics, and most of them it was just 1 mark. The students were quite happy. They were like, there was such an easy question, and most of them wrote just this. Little did they know you had to apply this rule. And it was A1, which means if your answer is correct but rounding off is wrong, you'll lose a mark. Fine. So if I use calculator, if this is my final answer, I will have to search for the decimal places. So this one has 3 decimal place, this one has 2. My answer should should be rounded off to 2 decimal place. Multiplication division, however, is different, and it involves under root, etc., as well, square, whatever it is, any power, it will be under this rule. So the rule to round off final answer in multiplication division is significant figures. So you have to keep the least number of significant figures. So for example, if I look at this one, 3 times 0.789, so I'll not look at decimal places, I'll look at significant figures. So this is 1, this is 3 significant figure, and if I multiply, I get 2.367. My answer should be just 2. Reason being 1 significant figure and 3 significant figure. We have to give our answer to the least significant figures. Okay? Now, similarly, in this case, if you do with calculator, you get this as your answer. So again, 3 significant figures and 2 significant figures. So we'll not look at decimal places, significant figures, right? So my answer should be अच्छा. इसके बाद जो important bit है वो errors and uncertainty. ठीक है, this is what we have to clarify. Every measurement has some level of doubt in it. Question ये आ जाता है कि why is there a doubt? If we have the right instrument, why is there a doubt in the first case? फिर तो हमें चाहिए कि मैं clear हूँ. एक object है and I want to measure its length, and if I place a meter rule, why is there a doubt? It should be clear कि अगर मैं यहाँ पे divisions देखूं and let's say it is whatever 16, 16.1, 2, 3, 4, then 5, 6, 7, 8, and then 17 and so on. So question ये है कि why is there a doubt? हम कहते हैं कि uncertainty, and it's an important topic over here. It refers to the margin of doubt in a measurement. ठीक है, मतलब I'm placing the eye level completely perpendicular just to make sure there's no doubt, there's no error. Even no matter how much I try, there is always going to be a doubt in measurement. And the sad part is we can't eliminate. No matter how much you try, it will be there. ठीक है? So approach क्या है? We just have to deal with uncertainty. We have to deal with the doubt. We can't eliminate it. अब ये exist करेगा. ये physics में आप नहीं remove कर सकते. No matter what level of laboratory you have, every measurement in physics has a doubt in it. ठीक है? Doubt का मैं idea बता देता हूँ. देखें, if I observe it carefully, let's say if I take a screenshot and I zoom it, you see the gap between division. ठीक है? This gap cannot be eliminated. मतलब अगर मैं और ज़्यादा precise instrument use करूँ, right, and I zoom it further, maybe this other instrument that I use has more divisions, then I might think I'll be able to remove it. But if I zoom in further, chances are my divisions and the object, it will have some gap in it. Okay? So the reality is, if you record any reading, divisions and object, they don't usually match. What instrument does, ये आपको rounded off value दे देता है. ठीक है? This instrument is telling us the answer is 16.5, but there's a small doubt in this. इसको हम कहते हैं uncertainty. ठीक है? अब point ये है कि we don't have to worry about how to reduce it. Do I change the instrument, or do I take a picture, or do I zoom in, or what do I do? We don't have to go into further detail on what to do. All we have to do is just cater it in our values. मतलब हमने सिर्फ इसको associate करना है हमारी readings में. So the way to deal with this doubt is, whenever we take a reading in this chapter and some part of paper 3, this is how we are going to write the uncertainty. We'll write plus minus, which shows that the reading is on either side, the actual object may be on the either side. So we'll write plus minus with it. And then the format that has been finalized is, it is usually taken as the smallest division. मतलब इस केस में अगर मैं सेंटीमीटर्स में देखूं, the smallest division is 0.1. The absolute error is the least count of an instrument. Commonly, ठीक है, मैं commonly इसलिए कह रहा हूँ कि कुछ जगहों पर हम half the least count भी ले लेते हैं, especially volumetric instruments में. अगर आप chemistry का P3 देखेंगे तो उसमें हम burette का half the least count लेते हैं. लेकिन physics point of view से we don't have to worry what to decide, do we take half या do we take the least count. Commonly हम least count लेते हैं. ठीक है. So least count is usually equal to the uncertainty of an instrument. So whenever we record data, and if they want us to include uncertainty, what we do is we include the least count as the uncertainty. Okay? They'll not ask about deciding, okay, do we take the least count or half the least count? Sometimes it is half the least count as well. यहाँ पे physics में what we have to do is we need to process it. ठीक है, हमारा ऑब्जेक्टिव ये है कि we should know, if I have two readings, one of the length is 1.9 plus minus 0.1, the other length is maybe the width of it is 2.5 plus minus 0.1. So the question is, what is the area and what is the uncertainty in area? That is what this topic is about. ठीक है, the topic is not about how to decide. मैं commonly बता देता हूँ कि commonly it is the least count, like as you mentioned, but our objective of this topic is to processing uncertainty. ठीक है, कि how do we process it further. So ये हमारा main objective है इस topic का. ठीक है, so I'll move a little forward, then I'll take your questions. Background पे this is more than enough. You don't have to go into further detail about the origin of errors, etc. बस इतना समझें कि जो अनसर्टेनिटी होती है वो प्लस माइनस से लिखते हैं, और साथ में जो मेजर्ड वैल्यू होती है उसका जो लीस्ट काउंट होता है, दैट इज द अनसर्टेनिटी. ठीक है, सो ये हमारे पास एक इसका बैकग्राउंड है. वी डोंट नीड फर्दर डिटेल अबाउट द बैकग्राउंड. अच्छा, अब पॉइंट ये है कि कुछ टर्म्स हमें आने चाहिए बिकॉज विल बी प्रोसेसिंग अ लॉट ऑफ अनसर्टेनिटीज. इस केस में this, the first term, which is 1.9, is known as measured value. मतलब जो वैल्यू यहाँ पे आ रही थी, प्लस माइनस के बाद जो वैल्यू हम लिखते हैं, it is called absolute uncertainty. इस केस में 0.1. There are two more terms which we have to be clear. One is called fractional uncertainty. Fractional uncertainty हम find करते हैं when we divide uncertainty by the measured value. So if I divide 0.1 by 1.9, this whole term is known as fractional uncertainty. Why do we need it? That's a different question. A percentage uncertainty, it is when you divide the uncertainty by measured value and you multiply by 100. मतलब अगर fractional uncertainty को into 100 करेंगे, that is known as percentage uncertainty. तो ये कुछ terms आपके पास आने चाहिए in this topic. Before we talk about the type of questions, इसके कुछ rules हैं जो हमें आने चाहिए on how to write uncertainty. देखें, रूल ये है कि uncertainty should always be one significant figure. तो अगर एक लॉन्ग क्वेश्चन है एंड यू आर फाइंडिंग अनसर्टेनिटी और आखिर में आप राउंडिंग ऑफ से ही नहीं करते, ठीक है, अगर आपने आंसर इस तरह लिख लिया, तो दिस इज इनकरेक्ट, सो दिस इज करेक्ट. अनसर्टेनिटी में वन सिग्निफिकेंट फिगर होना चाहिए. दैट्स अ वेरी स्ट्रिक्ट रूल. आपके राउंडेड ऑफ वैल्यू इन योर फाइनल आंसर कैन नॉट हैव टू सिग्निफिकेंट फिगर. दिस इज फाइन क्योंकि डेसिमल नहीं है, सो वी कैन ट्रीट इट एज वन सिग्निफिकेंट फिगर. व्हाट अबाउट दिस वन? इज इट करेक्ट और इनकरेक्ट? या दिस इज इनकरेक्ट बिकॉज दिस इज थ्री सिग्निफिकेंट फिगर्स. अच्छा, दूसरा रूल जो हम अप्लाई करते हैं, दैट इज measured value and uncertainty should have same decimal place. So if this is 1, then this should be 1 decimal place. ये match होने चाहिए at any cost. ठीक है, अगर match नहीं हो रहे, we have to round off something. लेकिन we have to make it equal. इसमें हमें fix करना होगा. You're right, it is not correct. एक 3 decimal place है, एक 2 decimal place है. फिक्स करने का तरीका आपकी बात सही है. इट शुड बी 0.98. अब इसको तो मैं फर्दर राउंड ऑफ नहीं कर सकता, ये फॉर्मेट तो सही है. सो आई हैव टू रिड्यूस डेसिमल प्लेसेस ओवर हियर. तो इसका तरीका ये है कि दिस इज द करेक्ट वे टू राइट इट. इसके डेसिमल प्लेसेस मैच नहीं हो रहे, सो ये इनकरेक्ट. अगर आप यहाँ पे मिस्टेक कर रहे हैं, सो यू आर लूजिंग मार्क्स फॉर लिटरली नो रीजन. आप इतना कैलकुलेट कर दो और आखिर में आंसर सही हो, ठीक है, मैग्नीट्यूड वाइज ये अगर आप कैलकुलेटर में ये आ रहा है और करेक्ट भी है, स्टिल यू लूज मार्क. ठीक है, तो फर्स्ट रूल, ये सारे वन सिग्निफिकेंट फिगर होने चाहिए. लेफ्ट एंड राइट इनके डेसिमल प्लेसेस मैच होने चाहिए. जरूरी नहीं है कि 1 हो. ये देखिए, टू डेसिमल प्लेस भी सही है. टू डेसिमल प्लेस एंड 1 सिग्निफिकेंट. अच्छा, so processing uncertainty में we will have to look at addition and subtraction first. For example, I have a length 3.0 plus minus 0.1 centimeters और एक और इंस्ट्रूमेंट से मैंने यूज किया, it was 5.5 plus minus 0.2 centimeters. ठीक है, कहीं पे I had to find L3 which is the sum of these two. And I want you to find L3 along with uncertainty of L3. This is how they are going to ask question. अगर आपको plus minus और delta ये नजर आए, it means they want the final answer, not just the magnitude of final answer. They also want the uncertainty in final answer. तो rule ये, addition of two values will cause uncertainty to be added as well. तो जब मैं L3 find करूंगा, I'll add 5.5 plus 3.0, तो L3 की वैल्यू आ गई 8.5. ठीक है, uncertainty in L3 will be equal to sum of these two. तो ये मेरे पास हो जाए 0.3. तो my final answer is going to be 8.5 plus minus 0.3. तो ये simple rule है. Subtraction का अगर example देखेंगे, अच्छा, so let us say I want to find L2 minus L1 and let me call it L4. कोई और length था या कोई value है, I have to find P और P का formula ये है कि L2 को L1 से subtract करना होगा और question ये है कि find P plus minus uncertainty in P. तो पहले अगर मैं P find करूँगा, L2 minus L1 ये मुझे वैल्यू दे देगा 5.5 minus 3.0, ये क्या आ जाएगा 2.5, राइट. सो ये मेरे पास P की वैल्यू होगी. Uncertainty in P क्या होगी? Whether values are subtracted or added, uncertainty you can't reduce it. The level of doubt will always increase. So uncertainty will still be added. So P का final answer जब मैं लिखूंगा, when I'm to submit my answer, I'll write it like this: 2.5 plus minus 0.3. तो ये रूल नोट कर लें कि एडिशन सब्ट्रैक्शन में एब्सोल्यूट अनसर्टेनिटीज आर एडेड. ठीक है, वैल्यूज बेशक देख लें. L3 में they had to add the two values, so we added 2, 4.8 आ गया. Uncertainty भी add होगी. And even if we were to subtract two values, तो subtraction से इसका आंसर 3.0 आया, लेकिन uncertainty is still going to be added. ये पॉइंट क्लियर है कि whether you're finding the difference or if you're finding the sum, uncertainties हमेशा ऐड होती है और ये आपको ज्यादा यूज होगा आपका टेम्परेचर चेंज के क्वेश्चंस में and they'll ask you to find initial and final temperature. तो ये ना हो कि आप चेंज में uncertainty को subtract कर दें. So although the temperature are subtracted final from initial, uncertainty will be added. अच्छा, multiplication division में percentage uncertainty in final value is equal to sum of individual percentage uncertainty with powers becoming the coefficient. A little long and difficult to process, it seems so, but बेसिकली काफी आसान बात है ये. आप रूल लिख लें और इस पे जरा सोचें इसका मतलब क्या बनता है. लेट्स से ये हमारे पास एक फॉर्मूला है. तो एक फॉर्मूला है g is equal to 2h by t square. ठीक है, डिवीजन हो रही है h और t square. What we have to do is we need to link the percentages uncertainty. ठीक है, रूल ये है कि percentage uncertainty in final value, फाइनल वैल्यू इस केस में जो सब्जेक्ट है जी, इसकी जो परसेंटेज अनसर्टेनिटी है इट इज इक्वल टू व्हाट, सम ऑफ ऑल द परसेंटेज अनसर्टेनिटी. तो इस वक्त हमारे पास दो फिजिकल क्वांटिटीज हैं एच एंड टी स्क्वायर. सो आई राइट परसेंटेज एच प्लस परसेंटेज टी. ठीक है, सम ऑफ इंडिविजुअल विथ पावर्स बिकमिंग द कोफिशिएंट. किसी का अगर पावर है 2 या 3 या व्हाटएवर, that becomes a coefficient. This is the first step that you have to do in percentage uncertainty questions, even if you don't understand what is going on in the question. But if you see some term like percentage uncertainty and if you see a formula which has multiplication division involved, a पहला step तो कर लें कि convert this into percentages. Is 4 3 are they physical quantities? Do I consider them? We will not consider 4, 3. What about pi? It's not a physical quantity. Pi is just a ratio of 22 or 7. So ये भी consider नहीं होगा. Then what are we left with? Radius. 3 percentage R exactly. Power होता है, calculator से आप try कर लें, it's 1/2. ये under root होता है. Power 1/2 होता है. Cube root square जो होता है 1/2 होता है. ठीक है, क्यूब रूट 1/3 होता है. तो मतलब कि आपके पास रूट जो होता है वो पावर ऑफ फ्रैक्शन होता है बेसिकली. ठीक है, तो एल स्क्वेयर होता है, बट एल पावर जो अंडर रूट होता है वो एल पावर 1/2 होता है. ये एक ही बात है. 1/2 परसेंटेज एल, क्योंकि एल अंडर रूट का मतलब ये इसका पावर एक्चुअली हाफ है, एंड 1/2 परसेंटेज जी. सो यू आर एबल टू अंडरस्टैंड दिस, बाकी फिर वी विल बी एबल टू डू इट. ठीक है, एक और एग्जांपल मैं क्विकली गो थ्रू कर लेता हूँ. इसमें हाफ को नहीं कंसिडर करना, ये तो नंबर है. सब परसेंटेज एम प्लस 2 टाइम्स परसेंटेज वी. तो ये हमारे पास सारी डिस्कशन थी. सिंस वी आर इन अ पोजिशन टू कन्वर्ट परसेंटेजेस, विल गो फॉर दिस simple question initially. November 20, a steel ball is dropped, falls through vertical height. So whatever background information they are given usually is not required. We have the height and uncertainty, and we have the time and uncertainty. The formula is given. So h is 1/2 gt square. They're asking for the percentage uncertainty of g. So based on this formula, what should be our first step? What do you think? Yeah, I think we should go for making g the subject. Okay. So g will be 2h over t square, right? If you want to find percentages, yes, you divide and multiply by 100. Percentage h, because it's a multiplication division formula. So all the variables will be added. So 2 times percentage t because of this square. This 2 has no role. And then what we have to do is the percentage h is clearly visible from this data. Okay, the one Fatima you mentioned about 100, I think. So we'll divide the uncertainty, the absolute uncertainty, and multiply by 100, 0.246. So instead of h, I'll put 0.246 plus 2 times percentage t. Can you convert this into percentage? Kisa theek hai, 2.19. So what do we get as a whole? plus 0.246. What do we get? I think 4 point something. 4.6. Only one option in 4. So B is the correct answer. Yeah. A student applies potential difference of this. Resistance is given, time is given. The student calculates the energy. So we have the final answer, but we don't have the absolute uncertainty. That is what they are asking. मतलब हमारे पास E की value है, it's the plus minus delta E which is missing. So देखिए multiplication division है. So there are different ways to go about this question. My suggestion is stick to the percentage. It makes the question a lot simpler. There are in different books different approaches like fractional uncertainty and so on. I would suggest stick to percentage. Percentage uncertainty wise, if I want to find percentage first, because if I have the percentage, just find that percent of 80 and that is the answer. Yes, percentage voltage, percentage time plus percentage resistance. Is this equation fine? Yeah, do I have to add anything?
There is your potential difference that will be multiplied by 2.
Yes, Malaika, you're right. We have to consider the square. So yeah, we'll multiply by 2. Yes, Sadia, you're right. Now, finding percentage is not an issue. How much is the percentage of V? 0.1 by 4 into 100 करें क्या आता है? Do write this formula, all of you. Then write this, ताकि steps clear हों, especially theory के लिए. Anyway, इससे क्या आता है? 0.1 by 4 into 100. 0.25 आ रहा है ये क्या? 2.5, right. And what about percentage T? 1 by 50 into 100. ये तो 2 आ गया. And percentage R 3%. ठीक है. 0.3 by 10 into 100. 3%. तो ये क्या आ रहा है? 5 plus 5. Is it 10%? Right? इसमें किसी का क्वेश्चन है? This is 10%. But that is not the question. ठीक है, क्वेश्चन आप लोगों ने गौर से रीड करना है. दे आर आस्किंग फॉर एब्सोल्यूट अनसर्टेनिटी. देखिए, इफ यू हैव द वैल्यू, ई की वैल्यू है और ई का परसेंटेज है, यू जस्ट हैव टू यूज परसेंटेज ई बाय 100 इनटू ई. सिर्फ उसका परसेंट फाइंड करें ना. मैं अगर आपसे कहूँ कि 80 एक वैल्यू है, उसका 10% कितना होता है? ठीक है, तो या तो आप फॉर्मूला पे जाएं, परसेंटेज ई में डेल्टा ई बाय ई इंटू 100 में डेल्टा ई को सब्जेक्ट बना लें. Either you can memorize or you can just use concept. What is 10% of 80? तो वो आप कर सकते हैं. ठीक है, परसेंटेज ई को मैं चेंज कर रहा हूँ एब्सोल्यूट में, तो जस्ट फाइंड 10% of 80. Yes, उसे you're right, 8 जूल. तो हमारे पास ये आंसर आ गया. अगर ये थ्योरी का क्वेश्चन होता है, I would have written like this: 80 plus minus 8 would have been the answer. So you have to look at the question. If they're asking about percentage, we stop at this point. If they're asking about absolute uncertainty, so just find the percent of the final value. So percent को 100 पे divide करके e से multiply कर लो. Make sure you note this down. अच्छा, June 22. What is the percentage uncertainty in volume of the sphere? Diameter is given. But you have to rely on the formula. ठीक है, वॉल्यूम की बात हो रही है. ठीक है, वॉल्यूम generally for a sphere is 4 pi 3 pi r cube. So make sure you note down this formula. Generally diameter is more preferable. हम पेपर 3 भी देखेंगे, जब भी क्वेश्चन आएगा उसमें जो फॉर्मूला होगा वो in terms of diameter होगा. And so is the case with MCQs and theory. Deformation में ज़्यादातर diameter of wire जब use होंगे, they'll never ask you to talk in terms of radius. They'll ask you to talk in terms of diameter. ठीक है, तो preferable ये है कि rather than sticking to this radius formula, if data is in diameter, it's more appropriate कि formula भी diameter के terms में बात करें. तो diameter के terms में एक और इसमें 8 आ जाता है, because radius is diameter by 2. तो जब आप cube लेते हैं to replace, तो फिर ये d cube by 8 हो जाता है. तो my suggestion is कि आप ये formula use करें, 4 by 3 into pi d cube by 8. Radius के साथ problem ये है कि it is never a measured value. We don't have any instrument which can measure radius. Radius is always a calculated value, and physicists, they base their ideas on measurements. तो diameter जो है, it's a measured value always. ठीक है, you have multiple instruments which can help you measure diameter. रेडियस जो है एक सेकेंडरी क्वांटिटी है जो कि कैलकुलेटेड आती है. So there's a difference between calculated quantities and measured quantities. Measured जो है वो ज्यादा डिस्कशन में आते हैं. ठीक. तो anyway ये दोनों फॉर्मूलाज नोट कर लें कि रेडियस के टर्म में जब रेशो एटसेट्रा के क्वेश्चंस यूज द लेफ्ट फॉर्मूला. डायमीटर का जब क्वेश्चन आएगा, और दिस इज नॉट द ओनली टाइम दे आर giving data in diameter, we'll come back to this topic, diameter versus radius, again in deformation, and we'll come back again in electricity, where we'll be discussing number density and factors affecting resistance of wire, where a common way to ask question is in terms of ratio. तो वहां पे अगर आप unnecessary divide by 2 करेंगे, that will create confusion. तो बेहतर ये है कि आप ये फॉर्मूला नोट कर लें. ठीक है. पॉइंट ये आ जाता है कि परसेंटेज वॉल्यूम की अनसर्टेनिटी फिर किसकी इक्वल होगी बेस्ड ऑन दिस सेकंड फॉर्मूला. How do I complete this equation? What do I do? Percentage v will be equal to what? 3 times percentage d. बिल्कुल you're right. So d में आप जो है जब आप इसको डिवाइड करते हैं, so I think 0.2 आता है. Your answer should be 0.6. So C is the correct answer. We can start with 1.4, which is random error and systematic error. This one is the descriptive part of the chapter. So random error, self-explanatory. खुद इसको जरा read करें. Try to understand what is written. So I want you to go through this. It's a type of error which causes measured value to be on either side of true value. Meaning what? There's no trend in measurement, and values may lie above or below true value. An example is if there is an experiment and I want to measure the value of G, which is 9.81, and I keep on repeating the same experiment, but sometimes I'm getting less, sometimes the exact value, sometimes more. I don't see a trend in my measurements. This is known as a random error. So there is an error, but it's not specific. Now, to deal with random error is just take an average and you'll be able to eliminate the random error. Okay? So there's no need to debate on what are the examples, and sometimes the example can be random or systematic, both or whatever. It all comes down to the nature of the error. If you see randomness in the measured value, it is a random error. Even like parallax error can be random. What if I'm repeating the experiment and every time I'm measuring from different angle? So that is causing an error, and that error is not specific. So even parallax error can be an example of random error. Okay? Usually careless observation or some factor which is not constant. Okay? That's a random error. But if you see a clear trend in the error, then we call it a systematic error. Like we have to stick to the nature of error. So for example, again, I'm repeating an experiment and I want to find the value of acceleration of free fall. And every time I'm getting a value smaller, it means there's a very clear trend. Either my instrument are at fault or there's zero error. Something is causing all the values to drop. This type of error is known as systematic error. Now, if I want to fix this and I take an average, that will not help. So average is not a solution for systematic error. Systematic errors such as zero error calibration, formula, instruments, etc. I need to fix the issue by observing where the error is. So it may be zero error or calibration or even the formula. Maybe I'm using an incorrect -2 or whatever, which is causing all the values to be less. So if you are able to observe a trend, it's a systematic error. If you are unable to observe a trend in the error, then it's a random error. And today we'll discuss few questions related to it. Which statement about systematic error is not correct? Random error can be reduced. You cannot reduce systematic error. Fine. And they are asking for the false statement. If you look at other options, A is correct because that can cause a systematic error. same amount. That is what systematic is. Acha, we have few more terms. This is a relatively small topic, so we can just quickly skim through these terms. A precision is a measure of closeness in repeated value. Now think over this by looking at an experiment, and we are measuring some length, maybe length of a pencil or whatever. And then the other experiment, using the same object, we had a different set of values. If the range is small, I can clearly see the degree of closeness was more. Hence, experiment A is more precise. The highest value is 5.2 and the lowest is 5.0. Range is 0.2. Whereas if you look at the range in experiment B, the highest is 5.1, 5.9 and lowest is 4.8. The range is 1.1. So the smaller the range is, more precise the value is going to be. In other words, there's another way to look at precision. Precision is the measure of detail in a single experiment. So if you have 12.2 and then if you have 12.219, if you have more significant figures, then this is more precise. Accuracy is degree of closeness to the true value. If a value is accurate or not, until unless you have a true value, you cannot judge. For example, gravity. Now you already know gravity normally is 9.81. That is the true value. So if you're doing an experiment, if you're conducting some experiment, maybe kinematics, and you're finding acceleration of free fall, you already have that value in mind and you can compare the true value with your measured value. So if your average is 9.83 in some experiment and you're repeating in some other apparatus and the objective is to find 9.81, the acceleration of free fall, the true value is much closer to A. So we are going to say A is more precise. A is more accurate. So the more it is near to the true value, the more accurate it is. For accuracy, you need to have reference. Okay? Why am I calling this more accurate? Because it's more close to the true value. Acha, graphical representation dekh lete hain. Let's say on y-axis we have frequencies of values. Precision is how close values are to each other. We'll look into a few questions to understand this aspect. Acha, so, for example, I'm conducting an experiment and my average is off. Though the values are not too much spread out, they're quite close to one another, but I wasn't able to hit the true value. This is where my average is, so it's not accurate. Had my average been on top of the true value, gray overlap karta, फिर सही था. The range is not that much, so it is fine. And type of error can also be incorporated. Small range means less random error. And if there is lack of accuracy, it means systematic error is there. Why? Because all of the values, your overall experiment is above, like it's not spread out on either side. There's a clear increase in all the values. Sare values aage gaye hain. Whatever the factor was, but it is definitely a higher degree of systematic error and less of random error. अच्छा, यहाँ पे अगर मैं इस ग्राफ को देखूं, it's quite spread out, so मैं कहूँगा कि precise नहीं है. The observer was not very precise while measuring, but overall accurate तो है, because average जो आ रहा है वो true value के साथ match कर रहा है. X naught is the true value and the pointed brackets is the average. Systematic error is not there, so we don't have a specific trend of error. It's just values lying on low accuracy and low precision is also possible. So generally shape of graph should be familiar. Shape बेशक बना लें and just write wide range, less precise. Average matches true, so more accurate. Second line में आप बेशक लिख लें more random error, less systematic error. Saifa, what do you think about this one?
I believe it's more accurate.
Yeah, because the average and the true value matches and precision. Exactly. So that's just how you conclude the whole idea. ठीक है, बस आप रेंज देख लें, एवरेज देख लें. Quite simple. लास्ट केस ये है कि दिस इज द वर्स्ट केस कि ना हमने प्रिसिजन अचीव किया, वाइड रेंज, and there was some error which was causing all of the values to be on one side. trend ये नजर आ रहा है कि all the values are higher. So it has systematic error as well as random error, which means we did not achieve precision or accuracy. March 22, this very MCQ has been repeated. I think I've seen this 3-4 times in different past papers. भी आया है recently, फिर इन्होंने पूछा है March 22 में. अच्छा देखिए 10 plus minus 2, if we use our knowledge of percentage uncertainty, that is a lot of percentage uncertainty, 20%. Had this been like 1%, 2%, I would have said it's precise. ठीक है. But right now, too much of variation. Okay, it is not precise. What this information is telling us, okay, the value of G is somewhere from 8 to 12. Plus minus का ये मतलब आ रहा है ना, this is how we are uncertain. Isn't that a lot? Actual value is somewhere over here. So this piece of information is telling us the values between 8 and 12. So the statement is correct. So I'll go for the accurate ones, but the problem is with precision. C had not accurate, so C was wrong because of this part. So we want to see which one is not precise but accurate. Okay, so A should be correct. Right, I'll move forward. Achha. So that was about precision and accuracy.